आप सबका स्वागत है और आज हम लोग इस एनिमेशन के माध्यम से समझेंगे कि जो है सो डैम कैसे काम करते हैं, इसमें कौन से कंपोनेंट है, हर रियल लाइफ में इम्प्लीमेंट कैसे किया जाता है, किन चीज़ों को फेस किया जाता है। और ये हम लोग समझेंगे इंडिया के सबसे बड़े हाइड्रो प्रोजेक्ट डैम सुबानसिरी के एनिमेशन के थ्रू। तो इस वीडियो में बने रहिए। थैंक यू दोस्तों हमारे चैनल में आने के लिए। चैनल को सब्सक्राइब कर दें, वीडियो को लाइक कर दें, अच्छा लगे तो अपने बच्चों के साथ शेयर करें।
1000 megawatt and annual generation of 7421.59 MU. The project is a run-of-the-river scheme on Subansiri River, a tributary of Brahmaputra. The right bank of the project is situated in Arunachal Pradesh and left bank is in Assam. The major components of the project are a concrete gravity dam for storing water in the reservoir, 8 intakes to draw water from the reservoir, 8 head race tunnels for conveying water from the reservoir to the powerhouse, a surface powerhouse for housing the machineries to generate electricity, a 116-meter high and 284-meter long concrete gravity dam is constructed across the river to head up the water, 9 radial spillway gates, the biggest radial gates in the country, have been provided in the dam for safe discharge of the probable maximum flood of 37,500 cubic. A plunge pool has been provided to dissipate the energy of water released from the spillway with ski jump arrangement. Cut-off wall have been provided at the upstream and downstream of the dam to check seepage. The surface powerhouse of Subansiri Lower project is located on the right bank of river Subansiri. The powerhouse is designed to house 8 250 megawatt machines, transformer bay, GIS block and pothead yard. The auxiliary building, transformer bay, GIS and pothead yard are located downstream of the main machine hall. To isolate the machine from the water conductor system, MIB has been provided in the upstream just adjacent to the machine hall. Total 8 intake structures have been provided to draw water from the reservoir. Water is then conveyed through 8 9.5-meter diameter horseshoe-shaped head race tunnel to the powerhouse. Before entering the turbine, water is conveyed through independent vertical pressure shaft, where high head is generated to rotate 8 250 megawatt generators. 8 surge tunnels have been provided to protect the water conductor system from the water hammering effect. Along the penstock, a butterfly-type main inlet valve is installed to regulate the water inflow into the turbine during generation. When the main inlet valve opens, water starts to flow through spiral case, stay vanes, guide vanes and the Francis turbine runner, the heaviest turbine runner of the country, weighing 105 ton. The runner is coupled to the turbine shaft. Due to the water flow, the runner rotates, thus rotating the turbine shaft. Water after passing through the runner is channelized through the draft tube and TRC to exit into the tail pool. Rotating turbine shaft is coupled to the shaft of the generator rotor, the biggest rotor ever handled in a hydropower plant weighing 620 ton. This generator rotor creates a rotating magnetic field, which in turn helps in generating electricity through generator's stator windings. The generator transformers step up the generating voltage from 16 kV to 400 kV. GIS is used as switching system to connect the generating units with pothead yard and 400 kV transmission lines. Power generated from the project is evacuated through 6 400 kV and 2 132 kV transmission lines. 400 kV transmission lines are connected to the nearest PGCIL pooling station at Viswanath Chariali through 400 kV double circuit transmission lines. After electricity is generated, water flows to the river through the tail race channel. Out of the 8 turbines, one of the turbines shall always be in operation, which will ensure that a continuous river flow is always maintained throughout the year for ecological balance. The project would provide a great relief from the flood devastation being faced by the region every year since time immemorial by controlling the flood through regulated discharge of water in river. The project will allocate a part of its total generation as free power to Assam and Arunachal Pradesh. All 7 northeastern states and 5 western states will be benefited from the power generated from the project. Riverbank protection and erosion control measures have been implemented to cover the stretch up to 30 km downstream of the dam. Sustainable livelihood interventions have been implemented in Dhemaji and Lakhimpur districts of Assam, identifying the initial sectors as sericulture, piggery and handloom. A total of 470 crores have been allocated for these downstream developmental works. Various CSR programs and schemes have been implemented for welfare of the local populace of Assam and Arunachal Pradesh. This project has brought prosperity for local people as well as the region, boosting local economy and general improvement in living standard of the masses, providing employment to the local youths. About 90% of 7,000 people engaged in construction works are local, despite various hindrances faced from time to time. The project is now scheduled to be completed by June 2024, with estimated completion cost of Rs 19,293.71 crore at November 2021 price level.